Hello students, today we start with the lesson Force and Pressure for Standard 8. Before we study what is force and pressure, we see when is a body said to be at rest and when is a body said to be in motion. Now, a body is said to be at rest when it does not change its position with the immediate surrounding, and a body is said to be in motion when it changes its position with the immediate surrounding. Now, we take an example of a railway track on which there is a moving train, a platform and a bench on the platform. So, the bench on the platform is at rest with the surrounding, and the train which is moving on the railway track is in motion with respect to the immediate surrounding. So this example explains when is a body said to be in rest and when is a body said to be in motion. Now moving on to what is force. Now you must have studied what is force in the previous classes also. So now force is nothing but it is a cause which is in the form of a push or a pull. The force when applied on a body, it tends to change the state of rest or of motion, or it tends to change the shape and size of the body, and it also changes the speed and the direction of the body. So we take few examples here to understand force better. Now first example is of the road roller. Now if we try to pull a stationary road roller, it is set into motion. So there is a force acting in the form of a pull on the roller. Second example is of a car. Now, when brakes are applied on the moving car, the car stops. Third example, we take of a fielder. A fielder tries to stop the moving ball. He tries to catch the moving ball and tries to stop it by applying a force. Fourth example is of a swinging girl. Now, a girl sitting on the swing. We try to push the swing. What happens? It tries to speed up. So, it also changes the speed. So, these were the few examples to explain what is force. Now, if this force is applied in the form of a stretch or a squeeze, it tries to change the size and the shape of the body. Now we take an example of a rubber band. Now here I am stretching a rubber band. So this increases the length of the rubber band. So here a force is applied in the form of a stretch. So there is a change in the size. Now if I take an example here of a tube, a toothpaste tube, or if you take a gum tube. Now if I try to press here, what happens to it? It changes its shape. So when a force is applied in the form of a stretch or a squeeze, the shape or the size of the body changes. So what is force? Force is a cause, that is a push or a pull, which tends to change the state of rest or of motion, or it changes the shape and size of the body. Now force, we cannot see force, but we can see and feel the effect of force. Now force is expressed with both, that is the magnitude as well as the direction. So force is expressed with the help of its magnitude and direction, and force is represented with an arrow. It is represented in the form of F with an arrow above it. Now we see the unit of force. Now the SI unit of force is Newton and its symbol is N. Now the name of the unit is given by from the name of the English scientist, that is Sir Isaac Newton. Now we will see what is 1 Newton. Now 1 Newton is that force which when applied on a moving body of mass 1 kg in the direction of the motion, it tends to increase the speed of the body by 1 meter in 1 second. Now we have read that all the bodies are attracted towards the earth, and this force of attraction is its weight or the force of gravity. But the force of gravity is not the same at all the places on the earth. So if we consider a place and a force of gravity acting on a body of 1 kg mass is 1 kgf. So 1 kgf, which is equal to 10 newtons. So the relation between 1 kgf and newtons, that is kgf and newton, is 1 kgf is equal to 10 newtons. To explain, now if we want to hold a mass of 100 grams on our palm, so we require a force of 1 Newton to balance the mass of 100 grams on our palm. Now we see what is the turning effect of a force. Now when the force is applied on a stationary rigid body, the body moves in a straight line in the direction of the force. But when the force is applied on a body which is not free to move, and it is pivoted at a point. It is pivoted at a point O, and a force is applied at a suitable distance at a point A, then the body turns. Now the axis which passes, the vertical axis which passes through this pivoted point is called as the axis of rotation. Now the factors which affect the turning effect of the force are, the first factor is the magnitude of force applied, and the second factor is the perpendicular distance from the pivoted point. Now, more the magnitude of the force, more is the turning effect of the body. More the perpendicular distance from the pivoted point, more is the turning effect on the body. Now to understand this better, we take an example of a door. Now the door, here there is a frame of the door. Now this is the hinge over here at which the door can be pushed and pulled. Now if we try to apply a magnitude of force and try to push the door from the point R, it won't be easy to push the door. Though a suitable force is applied, still the distance from the pivoted point is very less. So there will be difficulty to push or pull the door. Now, if we change the distance to the point Q, still there will be difficulty in pushing the door, though the same magnitude of force is applied, because the distance is still less. But if we increase the perpendicular distance from the pivoted point to point P here, that is the handle of the door, and try to push the door or to pull the door, it will be more easier to open and close the door. That is because the same magnitude of force is acting on all the points, but the distance from the pivoted point is now increased, because the second factor which affects the turning effect of the force is a perpendicular distance from the pivoted point. So the turning effect depends on the magnitude of force. Larger the magnitude of force, larger is the turning effect, and the perpendicular distance from the pivoted point, that is, more the perpendicular distance from the pivoted point, more is the turning effect. Now one more example to understand this better, we take a hand grinder. Now if you look at this hand grinder, now this point over here is my axis of rotation, the vertical axis of rotation or my pivoted point, and the handle which is fixed at the edge of the grinder on the upper wheel. Now this is at a particular distance, but if the handle was fixed at a closer distance from the axis of rotation, it would be rather difficult for us to turn the wheel. But just because the distance from the pivoted point is increased, so it will be easier to rotate the wheel. Now we will see what is moment of force. The moment of force is the product of magnitude of force into the perpendicular distance of force from the pivoted point. Now if we consider a body, and it is pivoted at a point O, then a force is applied in such a way that it is perpendicular at the pivoted point. So the body turns. So now moment of force is the magnitude of force which is applied, that is F, into the perpendicular distance at which the force is applied perpendicular to the pivoted point, and that is given by OP. That is OP. So a moment of force is given by the magnitude of force into the perpendicular distance of the force from the pivoted point. Now moving on to unit of moment of force. Now the SI unit here is, now force is given in, it is written in newtons, and our distance, that is OP, is in meters. So our SI unit for moment of force is Newton meter, and the CGS unit is dyne centimeters. Now the moment of force, the gravitational units for moment of force is, we have, that is kgf meter, and here it is gf centimeters. Now we will see the relation of, that is, now we have here 1 Newton is nothing but it is 10 raised to 5 dynes. 10 raised to 5 dyne. So if we take 1 Newton meter, which will be equal to 10 raised to 5 dyne into meter, that is 10 raised to the power 2 centimeter. So we get here 1 Newton meter, which is equal to 10 raised to 7 dyne centimeter. Now here 1 kgf meter is equal to 9.8 Newton meter, and we have 1 gf centimeter, which is equal to 980 dyne centimeter. We see what is pressure. Before that, we see what is thrust. Now, if we know that force can act on a surface in any direction, but if the force is acting at a normal to the surface area, if a force is acting normally on the surface area, then it is called as thrust. So the force acting normally on a surface area is called thrust. Now, if an object is placed on a surface, it exerts the thrust on the surface which is equal to its own weight. So, the unit of thrust is similar to the unit of weight and force. So the unit of thrust is, we have kgf, that is kilogram force. Then we have gf, that is gram force, and Newton N. So I repeat here. Now, force can act on a surface in any direction. But if the force is acting normally on the surface area, it is called as thrust. And if an object is kept on a surface area or it is resting on a surface area, it exerts a thrust which is equal to its own weight. Now the unit of thrust is same as the unit of weight and force, which are kgf, that is kilogram force, gf, gram force, and Newton N. Now we see the relation, that is we have 1 kgf is equal to 1000 gf. 1 kgf is equal to 1000 gf here, but we know that 1 kgf is equal to 10 newtons. So we have here 10 newtons, replacing here we get it as 1000 gf. So we have here 1 newton is equal to 100 gf. Now we see the effect of thrust. Now the thrust depends on the area. Moving on to effect of thrust. Now thrust depends on the surface area. It depends on the surface area. Now larger the surface area, the thrust acting on that is less, and lesser the surface area, thrust acting on it is more. Now to understand the effect of thrust, we take two examples. Now first example is of loose sand. When we stand on the loose sand, our feet sinks into the sand. But if we lie down on the loose sand, our body does not sink that much in the sand. Now this is because larger the surface area, the effect of thrust is less when we lie down, and lesser the surface area, the effect of thrust is more when we stand on the loose sand. Moving on to the next example is of hammer and the nail. Now if we rest the flat end of the nail on a wooden plank and try to hammer it on the tip. We notice that the nail does not penetrate the wooden block. Now this is because of the surface area. More the surface area, less is the thrust. But if the same nail is being kept with the pointed tip on the wooden block and hammered on top on the flat end, you see that the nail easily penetrates into the wooden block. Now this is because the surface area here is less. So less the surface area, more is the thrust exerted on it. Now we see what is pressure. Now definition of pressure. Pressure is defined as thrust per unit area. So pressure is defined as thrust per unit area. So pressure is equal to thrust upon area. So we have P is equal to F upon A. Now the SI unit of pressure. SI unit of pressure is, now force is, the unit of force is Newton and the unit of area is meter square. So it is Newton per meter square, or it is Newton per meter square. Now Newton per meter square is nothing but it is Pascal, and the symbol for Pascal is PA. Now the name of this unit Pascal is given by the name of the scientist, that is Blaise Pascal. Now we'll see what is 1 Pascal. 1 Pascal is the pressure exerted by the thrust of 1 Newton acting on the surface area of 1 square meter.
Start.
Now the bigger units of pressure, the bigger unit of pressure is kilo Pascal, and the symbol for that is kPa, kilo pascals, where 1 kilo pascals is equal to 1000 pascals, where 1 kilopascals is equal to 1000 pascals. Now if the thrust is measured, in, that is kgf, and the area is measured in the unit centimeter square, then our pressure is expressed in the unit, that is kgf per centimeter square. And our atmospheric pressure is expressed in the unit, that is unit atmosphere, in unit atmosphere, where 1 atmosphere is equal to 76 centimeter of mercury column, which is equal to 1.013 into 10 raised to 5 pascals.